In this video, I will show you what are the different, what is a dialyzer and where do this dialyzer actually comes into play and what are different types of dialyzer. Okay, so this video will guide you in writing what are the points that has to be needed to needed to be explained from your side when it's asked in the bigger question. Okay, so dialyzer is the part in the artificial kidney system which the treatment actually takes place and where blood is freed from the waste products. It is the meeting point of two circuits. One is the blood circulates and other one is the dialysis fluid flows. So one is, so you should have two circuits, right? So one is blood circuit, another one is dialysis circuit. So waste product from the blood is taken in the and it is when these dialysis circuit and the blood circuit, where do they meet? They meet at the dialysis membrane, and when these two get meet due to the concentration gradient, pressure gradient, due to different osmo or due to diffusion and ultrafiltration techniques, the waste product gets separated. Okay, so there are different types of dialyzers available in the market. One is the parallel flow dialyzer, which is called parallel plate dialyzer as also known. So it consists of three polypropylene boards with the dialysing membrane laying between them. So the board are held firmly with the frame of top and bottom or fastened by series of bolts on the side. Rubber gasket runs along the periphery of the board to avoid leakage of both blood and dialysate. The dialysate enters to a stainless steel port and it is distributed grooves below the membrane of the each layer after flowing down to the longitudinal grooves. So when it is flowing, so what happens is when the blood or any fluid flows through the grooves or longitudinal grooves as such mentioned in the description, so their surface area of transition, the surface area for diffusion or ultrafiltration increases. Okay, so the each and every product is easily transmitted because of so many different effects such as capillarity effect and because of this gradient that is being produced naturally and so on. Okay, it is needs to be cleaned and rebuilt after each dialysis. So the single pass of body temperature dialyzer passes through the dialyzer once before going through the drain. So what is body temperature dialyzer is? So when there is these two fluids come into contact via dialyzer membrane, what happens is there is a loss of temperature. So in order to avoid the loss of temperature, the body temperature of the dialyzer should be maintained at the body temperature. Okay, but one of these things is this is an older type of a dialyzer. It's now it is no longer used. Okay, and now one of the commonly used hemodialyzer machine is 10,000 allo the deacetylated cellulose. As we saw in the membrane video, so deacetylated cellulose or cellulose is a majorly used dialysis membrane. Okay, the capillaries are jacketed into plastic cylinder of 18 centimeters. So these are some details that you should be knowing. And capillaries are sealed at end to end in each tube with elastomer. Capillaries are range from 200 to 300 mm internal diameter, thickness of 50 to 30 micrometer. Dialysis area is approximately, so when I say the dialysis area, so this area actually determines the flow of solutes between the dialysis membrane. Okay, flow of fluid between the solutions. Okay, between the blood and the dialysis. So the area is very much important. Priming volume with the manifold exclusive tube is approximately 130 ml. So that is very less. Blood is introduced and removed from dialyzer through manifold headers. Dialysate is drawn through the jackets. Dialyzer disposable, so shows the internal details of the hollow fiber. So the blood comes between this and the solution is coming through the so you see they are going in a very thin capillarity effect will be there, and they are exposed to this dialysate solution, and dialysate solution will result in the uh, what is that the diffusion and ultrafilter diffusion and the transfer of solutes, transfer of waste particle from one side of the blood to the dialysate solution, and the solution inlet comes here and it goes out. Okay, so by this way, and these are, and the blood flows through this, and these are all so what is the material? Cellulose is the material. Okay, you see in this side, if you see there are very all small tubules. So that is what they have told here. See, the capillaries range is very narrow and the length is very large, results in a very good capillary, and there are like 10,000 all out these tubes, and the solution flows over the tube resulting in diffusion, resulting in the flow of waste particles from the blood to dialysate. Okay, So what are the advantages is given reduction of infection risk, reduced operator setup time, sterilization also gets eliminated. However, use of disposable is an expensive procedure because you need to throw them and reuse. Okay, so these are some important two types of dialysis that are commonly used, and one of them has been become obsolete, while this hollow fiber dialyzer, even though they're expensive, they are being keep on used. Okay, for various different advantages. Thank you guys.